Hi, and welcome to Harper's World of Science. Today, we're going to be discussing the nature of light. What is light? What is it made up of? And why is it important in our lives? Hey, who turned out the light? Boo! So, light's really important because it helps us to see. Without it, we'd be blind. When I turn on my flashlight, something really wonderful happens. Light comes from inside this bulb and forms a beam because light travels in a straight line. But if it hits something, it can bounce and change direction. That's why if I put a little bit of dust in the air here, you can see this beam a whole lot better because the light bounces off of it and into your eye. It does the same thing too off of mirrors. Light bounces off here, and you can see the spot up there on the ceiling where the light beam hits the mirror. The light strikes the mirror and it bounces off at the exact same angle that it hits it with. So when it hits something and bounces off, that's called a reflection. A reflection. is super cool. Ah! Bright light! Ah!
So, we don't always have to carry around a flashlight in order to be able to see all the time. But we still need an outside source of light, like, say, a lamp or the sun. Now, how does this work if it's not a direct reflection? I've got here a laser. We've got here a mirror, just like we had before, and we have here a wooden block. And if you notice carefully, over here with the laser, all of it gets reflected, where when it strikes the wood, it all bounces off in random directions. Scientists call this effect scattering. It makes it so that way we can see everything around us. As light strikes a surface, it scatters in all directions. That makes it so we don't have to have light set in specific directions in order to be able to see.
Science is so cool! Now, another interesting thing that can happen with light when it hits something is that it can go through it. This is what happens with like glass or windows. But when it goes through it, it doesn't go through perfectly. Something happens to it. Let's take a closer look at it down here. I've got here a laser beam hitting a rectangular piece of glass. Now notice, as light goes through it, that when it's up here, it goes down in a straight line. But when I tilt it off to the side, it kind of bends. This is the way the light normally would travel through the air. But as I go through here, you can see how it bends down like this. When light bends, scientists call this refraction. Refraction. This happens because as light goes through the glass, it's harder for it to go through it, so it slows down. And it forces it to bend. It's kind of like riding in a shopping cart over in the mall. Let's try that. I'm here with the shopping cart light wave of science. We're going to be studying how light travels between two different interfaces, kind of like that air to glass thing that we were doing with the laser back in the lab. Here we have on the ground here a layer of asphalt going down here into this dirt. Now, we know that it's a lot easier for a shopping cart to move along the asphalt, but it's a lot harder for it to go forward inside this dirt. It takes a lot more force to push it around. The same kind of thing happens with light. You see, the light can travel very easily in the air, but in the glass it takes a lot more work. If I push this cart and it travels from the easy place to the hard place, we can see how it will move. Now notice how this cart bent out of the way. You see, when it hit the dirt, the front part of the cart grabbed at the dirt. It slowed down, forcing the cart to bend out of the way. This is kind of the same thing that happens with a light wave. as it hits an interface, it has to realign itself, and so it bends. That was like a lot of fun. Let's try it again. Light bending, totally awesome! So now we're back in the lab, and we know that light can reflect and refract. Let's learn a little bit more about the colors of light. Now, many years ago, people thought that white light was pure light, that it wasn't tainted by anything, and that colored light had stuff added to it. This probably came from their idea or their experience that whenever they made paint, they had to add stuff to it to give it color. But then there was a guy by the name of Sir Isaac Newton.
Yikes!
Newton wanted to figure out whether or not this was actually true. He wanted to understand the real nature of light. And so he heard about something called a prism. Now, a prism is just a triangularly cut piece of glass. These had been very famous in his day. People loved them because they added color to the light. They made rainbows everywhere. And as you can see that, the light travels through this prism, it gets bent. And it goes, and it has a rainbow here. We start off with violet or blue, violet on the top, going down to blue. Green's kind of a little harder to see with this source. Going down to yellow, orange, and then red. You could say that the prism was separating out the light, or you could say that the prism was adding light. Which one is right? I'm sure all of you guys came up with some really good ideas on how to be able to test this. Newton's way of being able to test whether or not, which idea was true, is especially awesome because it's simple to understand and it's very decisive. So what Newton decided was that if one prism could add color to white light, then two prisms could add even more color. And so this is what he did. So he set up his second prism. And you can see how we have our light going through it, and we have our rainbow that we saw before. And it goes and it hits this prism. You can see the shadow of the prism right here. I've set this up so it only catches the red light. So Newton's idea was, you have just the red light going through it, then you should have like reddish purples and reddish greens and things like that. But what he saw, if you look carefully here, as we go down here, here is the light from the prism. Now come in real close here so you can see it. If you notice, it's only red. There's a little bit of yellow there just because I caught a little bit of the yellow up here, but it's just red and yellow. No purple, no blue, no green, nothing. From this, Newton came up with two conclusions. First, that white light is made up of all the colors of the light mixed together. And second, that prisms only separate light. They don't add color to it. This can be seen in how the white light, which was made up of all the colors, separated out, and then we caught only the red part of it, and it stayed red. Now this totally awesome discovery changed the way that we looked at light. And a lot of wonderful discoveries have happened because of this throughout the years. So remember, in order to look at something, or in order to see something, light has to reflect or scatter off of it into our eyes. Second, light bends when it enters into another substance. And that third, white light is made up of all the different colors of light. Well, that's our show. Thanks for watching. My son and I have some awesome light laser spectral intensity measurements to take. See ya!